All right, we're starting a new chapter, chapter 6. So today's chapter is fairly basic. It's just learning a lot of new words. And that's basically what every chapter from now on is going to do. Everything in geometry, after the initial shock of geometry, and it is a little bit of shock because it's so much different, isn't it, than a regular math class? Would you agree? I think it's considerably different than algebra. I mean, even though we use algebra, I think it's really different. But once you get over that and you start getting used to it, it seems like you get this pattern where, okay, you're doing a new chapter, you learn new stuff, but you're really doing the same kind of things with just different figures, right? Different shapes. All right, so we did a whole bunch of stuff with triangles before, right? And then we found, missing sides, missing angles, right? Set things equal to each other, do some algebra, solve for x, plug it back in. Agreed? Haven't we done a lot of that this year? We're going to do it again on this chapter, okay? So the only thing really different as far as the math is concerned is just what the figures are and like what you set equal to each other. And what else did we do to things? We set things equal to each other. We added things up, set them equal to like 180, right? You add things up, set it equal to something else. It's that kind of thing. And basically you just end up, as far as the arithmetic, the math, the algebra is concerned, we're kind of doing the same thing like every single chapter. We just learn how to do it with different figures. In this chapter, what are we going to deal with, do you think? Quadrilaterals, that's right. Somebody tell me what a quadrilateral is. Four-sided figure, okay? And we've already discussed that. Remember that chapter we did all these polygons, right? We did 3 sides as a triangle, 4 is a quadrilateral, 5 is a what? What's 5? Pentagon. What's 6? Hexagon. 7's a weird one. I don't use that too much. Yeah, heptagon or septagon, okay? It depends on who you're talking to, which one they use. 8, definitely what? Octagon and so on, okay? So we are going to deal specifically with quadrilaterals. We're going to get really specific. We're going to talk about, today is basically just talking about a whole bunch of different quadrilaterals. So let's see, 1, 2, 3, 4, 5, 6. 6 different types of quadrilaterals we're going to discuss. All right, so you need to know the name of it. You need to know what it looks like, all right? And you need to know what's true about it. I'm going to give you some things that are true about it. This is equal to this. This is parallel to this. This angle is equal to this. These two angles add up to be 180 or whatever, okay? So you just have to know what is what. So let's just start off. So quadrilateral is basically just a 4-sided polygon, or just 4 sides, we'll say, okay? So quadrilaterals is a closed figure with 4 sides. So let me just draw just some random 4-sided figure, okay? Doesn't have to be, let's do this. Let's do, I don't know, we'll take it down like that so it doesn't look like something we're going to talk about a little bit later. All right, so let's say we have this 4-sided figure. So right now, what could you say this is, just by looking at it? It's quadrilateral, exactly. How do you know it's quadrilateral? 4 sides, and that's it. Right now, that's the only thing we know that about this. What we're going to do right now, though, is we're going to describe some of the things. Okay, what I mean by things, I'll show you what I mean. All right, so this line segment right there and this line segment, they are called the sides, right? Actually, there's 4 sides, so these are 2 of the sides, but these sides are across from each other. They're right across from each other. Notice this side right here does not touch this side right here. Everybody got that? All right, it touches this one and this one. This one also touches like the top and the bottom, but this left side and right side, they don't touch each other. We call these the opposite sides. This is not that difficult. This is just because we're going to use these words later. We're going to talk about we're going to have some theorems and some definitions of different quadrilaterals, and I'm going to talk about the opposite sides. So you need to know what sides are opposite each other. So these 2 sides are opposite each other, and I'll just put a double arrow there, is that all right? Just to show you that these are not opposite to these. These sides right here are opposite. Now, I don't know if they're equal. I don't know if they're parallel. I don't know any of that stuff, but I do know that they're what? They're opposite each other. Everybody got it? This side right here, I should have labeled them, but I didn't. And this side right here are not opposite each other. Why? Because they share, see that? They share that point right there, all right? Do the opposite sides share a point? No, they don't. So that's how you know if they're opposite sides. Everybody got it? All right. I'll tell you what. Let's get rid of a whole bunch of stuff. Get rid of that. And I don't know if this was quick or not. What I meant to do at the beginning was to group that and copy it. That way I could put it somewhere else. So we know opposite sides. So what about this? Now, what about the sides that do connect to each other? These two right here. We don't call them opposite sides. We've actually used this word before. Remember we did parallel lines cut by transversal. We did alternate interior angles, corresponding angles. Remember all that stuff? We had a thing called consecutive interior angles. Remember that? All right, but we're not talking about the angles right now. We will in a minute talk about consecutive angles. But right now, these two sides that actually meet each other, we call these consecutive, what? Not angles, but what? Sides, yeah. All right, so these are consecutive sides. That's easy enough, right? This is just a warm-up to what we're actually going to be learning today. But we're going to be talking about consecutive sides. We're going to be talking about opposite sides and all that kind of thing. So you need to know what I'm talking about when I throw those words out, all right? So, I mean, it's not going to be on a quiz where you have to, define consecutive sides or opposite sides. You just have to know what I'm talking about if I mention it, all right? So that's what we're doing. We all got to speak the same language. I mean, geometry definitely has its own language. Would you agree? There's so many words you've learned so far this year that you probably never heard before, and a ton more that we're going to learn. So it's got its own language, and we need to be able to speak the language. So what about this? You got opposite sides. What do you think I'm going to go to now? I went sides. Now what am I going to do? Somebody get the door. I'm going to do what? Angles. So let's talk about the opposite angles. So look at this angle right here, and look at this angle right here. Now, I don't know anything about them being equal. I don't care right now. Later on I will. But right now, I don't care if they're equal. I don't care if they add up to something. All I care is that they are what to each other? They're opposite each other, right? So those would be considered opposite what? Angles, all right? So these are opposite angles, all right? And we got one more. What do you think? Take a wild guess. Shouldn't be wild. It should be very good. It should be consecutive angles. So what does that mean? That means this angle right here and what? This one right here. See how these angles they share this side right here? These opposite angles, do they share a side at all? No, they don't. They're opposite. Okay, these are next to each other. That's why they use that word, consecutive. They're next to each other. All right, so these two angles would be consecutive. This one here and this one down here would be consecutive. Everybody got it? This one and this one would be consecutive, and this one right here and this one right here would be consecutive. All right, but this is just one example of the consecutive. So we call these consecutive angles. They're just next to each other. And again, you may not know where this is going, but I do because I just finished teaching the honors class. They just finished chapter 6, okay? Actually, they didn't finish it yet. We're almost done. Got like 1 or 2 lessons left in the honors class. So you're actually catching up to them, to tell you the truth. So I guess that's good. All right, enough of that. Now, this is what you came for. This is why you pay the big bucks to come to Red Lion, right? So you can learn this lesson right here. So these are going to be, how many did I say there were going to be? 6, I think. So here's 6 types of quadrilaterals. Kind of 6. It's kind of, right? Because one of them, did I spell that right? It's hard to write things when you're talking, especially if it's a big word and you got to sound it out and stuff. Anyway, types of quadrilaterals. The first one, we're going to actually, 3 of them are going to be what this one is. So this is like the main big daddy type of quadrilateral, okay? We're going to talk a lot about this thing, all right? Types of quadrilaterals. So here it is. And you've probably heard this word before, but I doubt you really know much about it. So it's called a parallelogram. You've probably heard that word before, haven't you? Yeah. I don't know if you know anything about a parallelogram or not, but you probably heard the word. So we're going to learn a lot about parallelograms in here. We're going to learn a lot. All right, so let's see, what is a parallelogram? Well, let me draw one for you. I'll just use the computer. Oops. I'll just use the computer to draw one. Now, technically, that would be a parallelogram. We definitely know it's a parallelogram, isn't it? I'm sorry. We know it's a quadrilateral. I'm a little under the weather today, so I have a hard time thinking. So we know it's a quadrilateral because there's 4 sides. But why is it a parallelogram? Well, I'm glad you asked, because that's what we're going to do. I'm going to slant this just a little bit. All right. So normally, if you see a shape like this, normally that's what people look at and view as a parallelogram. Even though the last thing that I had drawn, it looked like a rectangle, we're going to find out in a few minutes that a rectangle actually is a parallelogram. But I don't want to ruin the fun for you. Let's just stick with this right now. So what do I know about a parallelogram? Well, a parallelogram has 2 pairs of opposite parallel sides. Of opposite, I'll put the symbol for parallel. Remember that? The up and down parallel sides. Well, what does that mean? 2 pairs of parallel opposite sides. It means the opposite sides are what to each other? They're parallel, right? Okay, it says right there. 2 pairs of opposite parallel sides. So the opposite sides are what? Parallel. Okay, so that means these 2 are opposite sides, correct? And they're parallel to each other. Is that good enough? Is that enough to say that it's a parallelogram? No, because it says what? It says 2 pair, all right, of parallel sides. So it's not just 1 pair. That's another thing that we're going to talk about. We might even get to it today. Hopefully we will. All right, so you have 2 pair of parallel sides. Is it pairs or pair? If I said 2, is it 2 pair or 2 pairs? Right, because 2 is plural, right? You say 1 pair, even though there's 2 things, right? Yeah, so 2 pairs. I don't know, it just sounded weird when I said pairs. I knew it's what it was supposed to be. Anyway, here we go. So that right there is a what? What is this thing? It's a parallelogram. How do you know it's a parallelogram? Because what? It's got, 2 pairs of opposite parallel sides. Okay, so both pairs of opposite sides are parallel. You could write that down if you wanted to, if that makes more sense. Both pairs of opposite sides are parallel to each other. Everybody good? So if I just have 1 pair, it's not enough. I got to have what? 2 pairs. Both pairs. Okay? All right. That's the first one. That's the big one. Now, the next 3 that we're going to talk about are all types of parallelograms. So this is not just a parallelogram. It's also a what? What's the more general, broad category? Quadrilateral. That's right. So it's a quadrilateral, right? I don't have to know anything about the sides, do I? I just have to know I have 4 of them, okay? If I got 4 sides, it's quadrilateral, and that's it. That's all I know. But if I know specifically that both pairs of opposite sides are parallel, then I could say it's a what? Parallelogram. It's right in the word, isn't it? Parallel, okay? So that tells you something about the 2 sides, 2 pairs of sides. Make sense? All right, let's move on. We're going to learn some more stuff about parallelograms in another section, all right? But today, that's all we're going to learn about a general parallelogram. But we are going to get more specific. So we kind of like have a hierarchy. At the very top is quadrilateral. It's very broad, very general, just means 4 sides. Then underneath of that, to get a little bit more specific, we have a parallelogram. Okay, so it's a quadrilateral with both pairs of opposite sides. Then under that, under a parallelogram, we actually have 3 specific types of parallelograms. So let's discuss that. Did I copy this thing? I don't know if I did. Let's copy it. Just make it easier for me. Oh, actually, I didn't want to copy because I want to do this. I'm going to draw a picture, and I bet you anybody could tell me what you think that's supposed to be. What's this thing right here? Looks like a rectangle, doesn't it? Do I know right now specifically that it's a rectangle? Why not? Because what's a rectangle have? Good. No. You gotta stay here. I want you to learn this stuff, okay? You should have gone to the bathroom before. Unless it's a girl emergency. If it's a girl emergency, I'm not even going to ask. You can go, all right? But if it's just to go to the bathroom, you just wait until I finish this. All right. What about a rectangle? What do we know about a rectangle? Okay, well, it is a parallelogram. That's true. So I know the opposite sides are parallel. But more specifically than that. Well, that's not specific, though. That's real general. It is quadrilateral. It's true. It's quadrilateral. It's a parallelogram. But why, or how could I make this? How could I make this into a rectangle where I know that it's exactly a rectangle? What do you know about rectangles? Come on, think geometry, think angles, think something. What? What do you know about a rectangle? And they're equal to what? 90 degrees, right? You know a rectangle's got a right angle, don't you? Yeah? All right. Everybody just afraid to say or what? Or you just didn't think about it? Well, they do. They have right angles. All the angles are right angles. It's not just one of them. It's not just two of them. It's all of them, okay? So all four of these angles are, if they're right angles, all right, if you know, if it's a parallelogram and you have four right angles, then this is a what? What do we call it? A rectangle. So what is a rectangle? Well, oh, by the way, parallelogram has actually got a symbol. Let me show you how to write a parallelogram. So let's call this A, B, C, D. I should have shown you this earlier. Remember how we showed triangle? What was the little symbol for a triangle? A triangle, right. So what do you think the symbol for a parallelogram is? It's just a little tiny one of these, all right? So if I wanted to name this, I would call it parallelogram. And then you start with any angle. It doesn't matter which letter you start with, okay? I'd probably start with A in this situation. So what could you call it? You could call it A, B, C, D, all right? So we call this parallelogram A, B, C, D. You must have four letters to name a parallelogram, all right? So you got to have four letters. You can start with any letter, but you have to go in order around the parallelogram. You hear me? But it doesn't matter which direction you go. So I decided to start at A. You could have started anywhere. You could have started at B, C, or D. It doesn't matter, right? I happened to start at A, and I went to the right. Okay, I went clockwise. Everybody see that? All right, so I called it A, B, C, D. You could call it something else. Let's say I started at A. What else could you call it? A, D, C, B, right? Just go the other way. Just go counterclockwise. Everybody with me? All right. I didn't have to start at A. Now, could I call it this? Could I go from A to C? No, because that's not in order. Okay, I got to go in order. I got to go either around this way, or I start here and I go around this way. And you could have started with any letter you wanted to. So there's a whole bunch of combinations, aren't there? To me, that's the easiest, just in alphabetical order. All right, it doesn't have to be, though. Okay, it could be any order. So enough of that. That's how we name that. So the reason I thought of that is because of this. So if I want to talk about what a rectangle is, I say that it's a parallelogram with, that's my width, four what? Let's say right angles. Now, if they're all equal and it's four sides, they'll all be 90 degrees. Because how many degrees does that whole entire thing have? I don't think have we talked about it in here, or was that my honors class? I think it might have been my honors class. It's 360 degrees, right? So what's 360 divided by 4? That's 90. So yes, all four are equal, but specifically all four are right angles. So that is a rectangle. Let's do another shape. I don't know if this will be completely to scale. Come on. I have such a hard time grabbing these little things. They must have changed something on this program, because it used to be a lot easier to grab the sides. It seems like it was anyway. All right, let's take a look at this. Now, I'm telling you right now that this is a parallelogram. So they tell you that it's a parallelogram. So parallelogram, you call it whatever. I'm not going to put the letters on there, A, B, C, D. But this is a parallelogram. It's given. All right, that's what when they give you stuff, when they tell you stuff that's true about it, this is what they give you, that it's a parallelogram. Now, here's something that we know about this particular parallelogram. I know that all four sides are equal to each other. Okay? So I tried to draw it like that. It may not be perfect, but for the sake of argument, all four sides are equal to each other. So if you have a parallelogram, with what? Four equal sides, then we call it, anybody know what that's called? A rhombus. Very good. Again, this is a word that you may have heard before. You may have been able to pick out of a lineup, right, of different shapes. You may, oh yeah, that's a rhombus. But you may not have known what a rhombus really was. Well, it's a parallelogram with four equal sides. So that's the definition. It's a parallelogram with four equal sides. What's the first thing you think about as far as a four-sided figure with four equal sides? What pops in your head? A square, obviously, okay? But Is every, now this will make you think a little bit. Everybody stop writing and just think. Okay? Is every rhombus a square? No, because this is a rhombus and it's not a square, correct? Right? Is every square a rhombus? Yeah, because what's true about a square? A couple of things are true about a square, but one thing is all four sides are equal, right? So that's true about a square. It's also true about a rhombus every single time, all right? So what do you think the next figure we're going to draw is? A square. Very good. It's not that hard to figure out, right? So let's draw a square. So we know it's a square. It's under that umbrella of what? It's a, what's this? It's a parallelogram, right? With, what do we know about this square? 4 equal sides. Is that it though? And 4 equal angles. We'll put and. We'll put 4 right angles. It's true that they are going to be equal to each other. That's very true. But I just want to be a little bit more specific and say 4 right angles. Okay? So if I know that all 4 of these angles are right angles, well, guess what? This is also something else, though. A square is also not just a parallelogram, but it's also something else we've talked about. No, it's not necessarily. Well, yeah, it is a rhombus. That's true. It's a rhombus. That's very true. What else? What is it? Well, it's a all these things are quadrilaterals, but one of the specific things that we've been talking about, you know it's a parallelogram because I told you it's a parallelogram. It's got 4 equal sides, which makes it a rhombus as well, but it also has 4 right angles. What else has 4 right angles? A rectangle. Very good. A rectangle. Okay? So a square is basically a combination of what 2 things? A rhombus and a rectangle. Exactly right. Okay? And there's that. This part right here is because it's a rhombus. Right? The 4 right angles makes it a what? A rectangle. Is every rectangle a square? No, because you got to have a rectangle. It doesn't have all 4 sides, right? Is every square a rectangle? Yes, it is. Okay, because every square's got 4 right angles. Every rectangle's got 4 right angles. Yeah, so every square is a rectangle. Okay? Everybody good? All right, a couple more. How many we've done so far? 4 of them? All right. Now the next 2 that I'm going to do are not parallelograms. So just the 3, just the rhombus, the rectangle, and the square are parallelograms. All right. Now we're going to do something that is not a parallelogram. I'm not going to take the time to make sure this is perfect. I could, because this program would allow me to do that, but I'm just going to try to make it look as close as possible. All right, there it is. Now that's our, what's that? Our 5th one? Yeah, it's our 5th one. And watch what they give you. Let's just use different, I haven't been using any colors today. Let's use some color. All right, so I know that those 2 are equal to each other, and I know that these 2 are equal to each other. Okay? Now, this is not a parallelogram, so I can't start off saying it's a parallelogram, but I can say there's 4 sides, so it's a what? It's a quadrilateral, okay? So here's the definition, okay? So it's a quadrilateral with 2 pairs, of equal consecutive, this is kind of long, consecutive sides, but, all right, but what's true about the opposite sides here? Are they equal to each other like we said in a parallelogram? No, look, this side and this side would be opposite, wouldn't they? This got 1 tick mark, that's got 2. So what do I know about the opposite sides of this thing? They're not equal, exactly. Okay, so but whose opposite sides are not equal. I'll put that in all caps. Okay? What does this kind of look like? Maybe put a string on it. I could go outside on a windy day. What does it look like? Looks like a kite, okay? And that's exactly what it is, and we call it a kite. Even in geometry, okay? That's what we call a kite. Again, kite's a little different than a parallelogram, all right? Because you don't have any parallel sides, but you do have some equal sides, though, don't you? But they're not opposite equal sides. They're consecutive. Do you see it? Two pairs of equal consecutive sides. So these two sides right here are consecutive sides, and they're equal. These two sides right here are consecutive sides, but they're not equal. Look at the opposite sides. The opposite sides are definitely not equal to each other. So all that stuff has to be true about this. All right, so that was a little tricky. It's one that you probably haven't really grown up learning as far as your shapes. Would you agree with that or not? But you know what a kite looks like, right? Of course, kites could look a lot crazier than that, right? You got these dragon kites, you got all these different shapes and all that kind of thing. But your basic, everyday, ordinary kite looks like that. All right, so that's what we call a kite. All right, let's do another one. Last one. This is one that you've probably heard before. But you probably didn't study it very much, okay? Probably don't know a lot about it, but my guess is that you've actually heard. Again, I'm eyeballing this, so it may not be 100% accurate, but it should be pretty close. Actually, it really doesn't matter if these two sides are equal to each other. And in fact, let's do this. Let's do this. Let's bring that out to there. And let's connect, just so I don't mislead you. You'll see what I'm talking about in a second, all right? Yeah, I just heard it. Somebody tell me, what do you think this thing is? It's a trapezoid. Did you look in the book, or did you already know? Who's heard of a trapezoid before? Anybody? Yeah, everybody's probably heard of a trapezoid. Okay, I don't know how much you know about a trapezoid, but here's what it is. First of all, is it a parallelogram? Looks like these two sides are parallel, doesn't it? But what about the other two opposite sides? Definitely not parallel. So it's not a parallelogram, okay? But you do have one pair of opposite sides parallel to each other. And that's basically what the definition of a trapezoid is. It's a quadrilateral, so it's a four-sided figure. Obviously, we knew that. A quadrilateral with exactly, I'll underline that, with exactly one pair of parallel sides. I'll do the symbol for parallel. Okay? So you only have one pair of parallel sides, not two. So a parallelogram cannot be a trapezoid, because a trapezoid has what? Exactly one pair. No less, no more, exactly one. All right, so there you go. That's a trapezoid. Now, there are some things about a trapezoid we need to talk about. Probably not so much, maybe a little bit in this lesson, but there's another lesson we're going to do at some point. We're going to talk a lot more about this. But do you see the two parallel sides? We give that a name. We call that the base, both of them. We call the base of the trapezoid. Okay? Now, one base, they don't have to be equal to each other. In fact, they won't be equal to each other. All right? So, but those are the bases. The parallel sides are always the base. Right? We've kind of talked about this with triangle. Look, trapezoid and triangle start with the first two letters the same, don't they? Triangle, trapezoid. There's a lot of similarities, actually, between the trapezoid and a triangle. If you think about it, I don't know if you've even thought about it, but watch. I didn't do this for the other class. I don't know why. But watch this. What if I extended that side of the trapezoid, and I took this and I extended this side of the trapezoid? What did I form? A triangle. So it's kind of like a triangle, except we like whopped off the top of it, right? And we didn't just whop it off at any angle. We whopped it off, what? Parallel to the base of it. Everybody see that? So it's it has some similarities. Even like the area, remember area of stuff? Even the area of a trapezoid has a lot of similarities with this, all right? So anyway, let's do this real quick, because I've got an example I've got to do. And this is called the leg, right? We had legs and bases of triangles, so we got a leg and a base of a trapezoid. All right, let's do an example. We're going to do an example with a kite. Again, I'm going to draw this. It may not be super accurate, but it'll be pretty close. Something like this, something like this. All right. We're going to talk more specifically about a kite later on in another lesson, but let's take a look at this. This should be pretty easy for you. If that's 5y plus 2, this is 3 times y plus 2, that side right there. This is x plus 5, this side right here, and this one is 3x minus 1. We should have enough time to finish this up. And what they're going to do, and they say it's a kite, it's given. All right, it's given. What do they tell you? That this thing right here is a kite. So what do we know about a kite? 2 pairs of equal sides, not the ones that are opposite though, right? So which ones do you think are equal? This one and this one, yeah? And what else? Yep, these two down here. So what do you think we're going to do to be able to solve for x and y and then find the lengths of all the sides of the kite? Set them equal to each other, that's right. Let's do the x's first. I always like to do x first. So x plus 5 equals 3x minus 1. That's the geometry, just setting them equal. Remember I made a little talk at the beginning? That's basically what geometry is, knowing what things to set equal to each other, then you solve for it, plug it back in. We do that a ton in geometry. So let's do this really quick. Subtract an x from both sides, that gives us a 2x. Add a 1 to both sides, that gives us a 6. Divide by 2, what's x? It's 3, all right? And then that way, I can find this side, I can find this side. Let's do this one. This is the easiest one. This is x plus 5. So what's the length of this side right here? It's 8. Very easy. Okay, let's change colors. All right, so this side would be 8. Without doing any math whatsoever, what's the length of this side right here? That's also 8 because these two are equal to each other. Got it? If you wanted to, you could plug it back in. Let's do it. 3 times 3 is 9 minus 1 is what? 8. It works, doesn't it? That's always fun when it works. Okay, let's do one more and we'll be done. Let's take this, the 3 times y plus 2, and set that equal, because these two would be equal as well, wouldn't they? Right? See, these two are equal, these two are equal. Equals what? 5y plus 2. Let's do it super fast. That's 3y plus 6 equals 5y plus 2. Subtract a 3y from both sides. That'll give us a 2y. Subtract a 2 from both sides. That'll give us a 4. Divide by 2. What's y equal? 2. All right? So if I wanted to find these two lengths right there, just plug them in. Let's put it into this one. All right? So 2, put it in for the y. 5 times 2 is 10 plus 12 is... I'm sorry, I gave it away. I'm thinking what the answer was. 5 times 2 is 10 plus 2 is what? 12. All right? And then this is 12. Look at that. Saved by the bell. And we are done. I don't have my lesson plan open right now. Anybody got it in front of them? What's the numbers? So it's section 6-1. 1 through 18? Okay. 252? All right. So there you go. There's your assignment. You got the lesson plan anyway, but if anybody's watching on YouTube and they don't have a lesson plan, that's what it is. All right. Have a good rest of the day.